Hello everyone, we are at Beyond the Formula. Let's see that why does friction change when motion starts. Right? You might have seen that when you push a box, suppose you have a box here with some mass mkg. Now if you start pushing this box, if you start pushing this box, so it is harder. It is harder to push. It is harder to push, but once it starts moving, once the motion is started, it is easy to keep going, right? What do we say? Why is it harder to start moving? Why it is harder to start moving this box than to keep it moving, right? In this example we will see the dual nature of friction, that is involved here, right? So let's see, suppose for an example we have 10 kg of 10 kg mass block, right? So this will have 10 kg downwards, that is 10 into g, which will be equals to 100 newton, taking g equals 10 meter per second square, right? And this block or box will have the normal n, which will be equals to mg equals to 100 newton, right? Now suppose, now let's take the friction coefficient. Let's take the friction coefficient mu of s equal to say 0.1, right? Let's suppose mu of s equals to 0.1. Now if I have a person standing here and pushing the block with some force F, right? So what is the friction here? What is the Fs here? Fs is what? Mu s times n, which is 0.1 times 100, which is equals to 10 newtons. So if the external force this F exerted or pushed by the man is equals to 10, which is equal to less than 10 units, 10 newtons. Say I have 5 newton. Now this man is trying to push the block with 5 newtons of force. So what is the value of friction here? What will be the value of friction that will be applied, which will be equal to 5 newton. This Fs will be 5 newton. Now we have case 1 is if F equals 5 newton implies Fs equals 5 newton, right? Though the total friction here is 10 newtons, but if you push the block with 5 newton, the frictional force or the force of friction in the opposite direction will be 5 newtons only, right? Now if F is equals to 8 newton, if you push the block with 8 newton, the frictional force, the Fs, the frictional force will now change to 8 newtons. Fs equals 8 newtons. Now if F is equals to 10 newton, again the Fs equals 10 newton. Now this is the special case. We say is limiting friction. We say this as limiting friction or limiting value of friction. These two cases are what? Static friction. The frictional force required to keep the block in a static condition. Now if F is greater than 10 newtons, now if I apply any force greater than 10 newton, the friction force will be what? What will be the value of Fs here? Is it 10 newton? Is it greater than 10 Newton or is it less than 10 Newton? Right, so we will see that it is less than 10 Newtons. What will happen here? Now the Fs will change to Fk, which is called kinetic friction. Kinetic friction. Now the static friction will change into kinetic friction, and we know that mu s is greater than or equal to mu k. So this is the frictional coefficient for kinetic friction. So here mu k will be less than or equal to 0.1. That is why, suppose we take an example of 0.08. 0.08. So in this case, if suppose F is equals to 15 newtons, right, and mu k is equals to 0.08, which will imply that Fk will be equals to mu k times n, which is 0.08 times 100, that is 8 newtons. So we will have the net force is F minus Fk, which is 15 minus 8 newtons, which is equal to what? How much? 7 newtons, right? So in the previous cases where F was less than or equal to 10 newtons, the friction was static friction or limiting friction, nearly equal to 10 newton or less than 10 newton, right? But when F was greater than 10 newton, the friction changed to kinetic friction, and which is 8 newton constant, right? So this is the case where you see the nature of friction changes once start with static friction, then reaches the limiting value of the friction, and then when the transition happens from static to kinetic, then the friction value decreases to 8 newton, which depends on the kinetic friction coefficient. Correct? Thanks.